How do you enforce invariance? Define what must always be true. Examples: retry count never negative, payment cannot be success and failed, token cannot be valid and expired. Then encode guards in the module. Invariants are stronger than patterns. The big pattern across everything. React and Node are solving the same core problems. Core concern state, React component state, Node retry system retry state. Core concern transitions, React set state, Node retry system next retry. Core concern side effects, React use effect, Node retry system API calls. Core concern encapsulation, React component boundaries, Node retry system service class. Core concern immutability, React new state objects, Node retry system controlled mutation. Core concern invariance, React valid UI states, Node retry system valid payment states. Same structure, different environment. The real interview signal, they're not testing, do you know the decorator pattern? They're testing, can you control complexity? Can you model state safely? Can you isolate side effects? Can you reason about asynchronous? Can you protect invariance? Patterns are vocabulary. Structural reasoning is senior level thinking. Modules with libraries. You can use the module pattern when building applications with JavaScript. Libraries such as React. Let's say you have a large number of custom components created by your team. In that case, you can separate each component in its own file, essentially creating a module for every component. Here's an example of a button component customized from the Material UI button component and exported as a module. Import React from React and then import button from Material UI/core/button. So So if your team created a custom component, you can essentially create a module for that custom component. So here's an example. So here we import a button from Material UI and then we import React. So we create this constyle as an object and then we export this as a function called as a custom button with the props and then return the button and props, etc. So first, modern ES modules equal built-in module pattern. When you write export default function custom button, you are already using the module pattern. In ES 2015 plus, each file is its own scope. Variables inside are private. Export reveals what is public. This is just a modern form of the old module pattern. So basically it's just saying that in each of these files, since you create or you have a large number of components, variable inside these are private. Each of those has its own scope. Essentially creating a module for every component. So here is a button component customized for the Material UI, and then you export its function. So basically it is just showing us how this module was actually implemented in the modern frameworks like React. Export reveal what is public. This is just the modern form of the old module pattern. So when we discuss encapsulation, deep modules, hiding retries internals, protecting invariance, ES modules are the foundation. They enforce this file owns this logic. That's architecture, not syntax. Second, how this relates to React components. Your custom button example, export default function custom button props. What is this structurally? It is a module with private styling logic exposing a controlled interface props. This is exactly what we said earlier. React component is equal to deep module, kind of like making the most of the JavaScript module feature. As you can see, this custom button, uh, what it's what this means is that structurally, it is a module with a private styling logic that uh, expose a controlled interface called props. So it doesn't expose this implementation, only the controlled interface. Again, another example of implementation and interface. So those are actually being implemented in React module unconsciously. So deep module is small interface, hidden complexity. Custom button hides material, UI internals, styling logic, composition details. So as we saw in that module, we import another module, but those are hidden because our user only knows to enter prof as an interface on our module. So that's our custom module. Though we said that it's custom, that doesn't stop us from using like a third-party imports. So those things are API that you are actually seeing that brand themselves as custom might be just importing a lot of um, modules outside and then creating something out of it, which still not preventing them from calling it custom, because it's really a custom because it uniquely serve their purpose. It exposes props interface, that's architectural thinking. Third, revealing module pattern. Same principle as private fields. The revealing module pattern, let private counter equal 0 semicolon. Next line const public increment equal open and close parenthesis, then pointing arrow, open semicurly, dot dot dot, closing semicurly, then export default, open semicurly, then key value increment colon public increment closing. What is happening conceptually? Private state, public methods, controlled access. So we have this private counter as a state. So for example, this is a revealing module pattern. It's a module, but it keeps some private, it keeps some public, it controls the access. So it's the same with React as well, but here you see they have like kind of a different format, because here we start with a variable and with React we import something outside. So basically they have the same principles as well. Now connect this to our node retry discussion. Instead of retry count equal 10, you want retry.increment. You're protecting invariance. The revealing module pattern is simply encapsulation through closure. Modern version, ES modules, hashtag private class fields. Same principle, different mechanism. So again, ES module and the private class fields has the same principles, even with the revealing module pattern. It protects the invariance and encapsulation through closures. Fourth, the disadvantage, fragility, why this matters. Use of private functions referring to public functions can be patched. This connects to our earlier discussion on fragile state systems, tight coupling, async mutation bugs. When internal logic depends on external override, you risk invariant breakage. That's why deep modules should not rely on patching. They should rely on dependency injection, strategy injection, explicit configuration, same design principle. Fifth, singleton pattern. Now this connects deeply. Singleton, only one instance exists. Where does this show up? Front end, auth service, global state manager, back end, database connection, config loader, logger, retry registry. But here's the subtle point. Singleton is about coordination, not about only one object. It's about single source of truth. Now connect this to our earlier invariant discussion. Example, auth service must ensure only one active token state, consistent refresh behavior, no duplicated refresh rate, race. That's invariant enforcement via centralized state. How this connect to retry systems? Retry systems must have single authority over retry state, controlled transitions, central invariant enforcement. If you scatter retry logic across modules, you lose control. That's why we discuss encapsulation is greater than pattern memorization. The module boundary defines who owns state, who can mutate it, who enforces invariance. So for singleton, as you can see, it is being used for database connection, for auth service in front end, global state manager like Redux, a configuration, environment configuration, a logger, and a retry registry. So it's about one thing, a single source of truth. So the auth service must ensure only one active token state. It means it also prevents state leakage, consistent refresh behavior, no duplicated refresh race. That's invariance enforcement as well, just like with modules, via centralized state instead of different custom components. So in retry systems, we also have single authority over retry state. So a component wrapping up those payment function must have one singleton or single authority to enforce invariant. Control transitions from failure to from pending to failure or pending to success. You cannot have both. Central invariant enforcement. If you scatter retry logic across modules, you lose control. That's why we discuss encapsulation is greater than pattern memorization. The module boundary defines who owns it, who can mutate it, who enforces invariance. React modules versus Node modules, same philosophy. Concern encapsulation, React file module, Node retry service, service class. Concern private state, React component, hook state, Node retry service, private fields. Concern public API, React component, props, Node retry service, public methods. Concern side effects, React component, use effect, Node retry service, network calls. Concern invariance, React component, valid UI states, Node retry service, valid payment states. They're architecturally identical. React modules hide UI complexity. Node modules hide system complexity.